of years that have inherent IP associated with them. This is proprietary, it's free to operate, and it's exceptionally simple, fast, high quality, and high throughput. But what does this really do for us and for our customers? Whenever you're taking a gene to produce an enzyme, you never really know if it's going to express well. You don't actually know whether that gene in a fermenter can produce the protein that's required. So we test as many different combinations of factors to maximize the probability of successfully producing the enzyme of choice. And this cloning strategy that we've developed allows us to test multiple factors in parallel. So again, driving down the cost, driving down the time, specifically for the access to the first samples of enzyme that are then available for the customer. What I've just described assumes, of course, that the gene that you've identified will be recreated into a microbial expression system, and the microbial expression system will deliver this enzyme sample. And that's historically how enzymes are produced, using in vivo, so in-cell production using fermentation. We do this all the time. We have 3-litre fermenters, right up to 20-metre cube fermenters, producing small-scale quantities of enzyme and large-scale quantities of enzyme. But we thought to ourselves 12 months ago, well, how can we make this quicker? At the moment, this particular stage, accessing small quantities of samples for testing, is limited by the time it takes to grow the microorganism to produce the enzyme. So we invested in some technology that essentially is protein synthesis, in vitro transcription and translation to produce proteins instead of in a microorganism, in a machine. And we've spent really the last 9 months developing this as a new technology. And it's now proving its worth in allowing us to produce small quantities of enzyme instead of in 8 weeks, in 1 or 4 weeks, depending on the inputs. So we feel this is certainly a step in the direction to a groundbreaking new technology to offer enzyme samples much quicker and at much lower cost than using traditional in vivo tools. And essentially, this is what machine does. You provide an input that's your gene into a multi-well plate. It gets inserted into a glorified oven with lots of microbiological ingredients within each well within the microtizer plate. And over a series of less than 4 hours, we can turn a gene into a small sample of protein for subsequent testing to confirm that the activity is what the customer requires. There is nobody else that we've come across that's using this in the biocatalysis field, and we've spoken to a lot of people. It is being used for therapeutic protein production, but certainly the providers of the machinery, and there are very few globally who provide these protein synthesizer machines, are not working at the moment in the biocatalysis field. So we think this is a groundbreaking technology, and we are planning on developing it even further. So I'm nearly at the end of the presentation now. I've hopefully described to you how biocatalysts are looking to continue to open up enzyme possibilities to new and interesting markets and new customers. And to that end, what we're always striving to do is bring in new technology which allows us to access small quantities of enzyme for testing very quickly and at very low cost. And that's really just the start of the enzyme development process. What I haven't described is how we've developed lots of technology, process technology, to continue the rest of the enzyme process scale up in the same fashion, i.e. low cost and in a fast fashion. And unfortunately, time doesn't permit me to talk in too much detail about that today. But the whole premise of what biocatalysts are continuing to do is reduce the barriers to entry for biocatalysts, and we're really enjoying doing that. So this is where we are, and we have plans, significant plans ahead to introduce even more technology in this whole area of enzyme development, with significant targets that we put in place for ourselves with regard to making it even easier and cheaper to access, or more cost effective to access enzyme within the next 5 to 6 years. And to that end, only 4 weeks ago, the board at Biocatalysts approved a significant investment over the next 3 years, which is combined effort of assets, new people and new technologies, equating to about 8 million euros, which is designed to take us down this strategy of getting enzyme development even cheaper and even faster. So that brings me to the end of the presentation. I hope you've enjoyed it. Thanks very much for listening. My details, or certainly my email address, is shown on the screen here. There's also a generic email address if for any reason you don't want to contact me, that's fine. And we of course have our website, and it'd be great if you guys could take a look at that. So thanks very much for your time. Thank you.
Thanks, Andrew. Great presentation. Questions for Andrew? We've got time for a couple. Hard to see hands from here, so if you do have a question, stand up. It's probably easier to catch it.